Thank you, Andy. So my name is Steve Cousins. I'm a graduate of Stanford. I was here 20 years ago. I was remembering that I had somewhere I couldn't find it, or I would have brought a picture of my son riding on one of the Stanford robots when he was 18 months old. He's now 23, so I'm giving away a little bit about my age. And things have changed a lot in those 20 years. So if I can describe what it was like here in Ela Norbosch, if you know him, who's been a Stanford, he's been a CMU professor for the last 2 decades, maybe, since he left here. He was my TA in this class. What we had was a robot that had a ring of sonars around it, a ring of IR sensors around it, so 16 numbers, right? And our goal was, we were still in Margaret Jacks at the time, to drive from one intersection in a corridor to another, right? So just, you have a map of it's a very simple map. It's basically a connected graph. You want to get from point A to point B and try not to get lost. It was enormously hard work. It took us all semester to get it to do that. We were using MacBooks or whatever the original Apple laptop was, powered on top of that robot. And we were most of the time able to get it to go to that spot. And we said, like, wouldn't it be cool if we could get it to go like across campus or something? This was the big thing. It was really hard. And I asked this question, like, what would you, even if you solve this, what would you use it for, right? And now I find myself 20 years later building a robot that's very similar to that. We've solved that problem, and I think we found a use for it. So that's kind of what I'm going to talk about. The other story I'll tell just briefly about my long ago history is my first robot that I encountered, and I'll use the word robot in quotes there. I had a robot or my sister got a robot she was hit by a car. She was okay, but she was in the hospital, and when she came out, somebody gave her this amazing $100 toy. In those days, it was a lot of money. She was 2 years old, so that was like almost 50 years ago. And it was a remote-controlled doll. And it was the coolest thing. And I realized that what's cool about robots is we can make them do action at a distance. We can impose our will on them. We can ask them to do things for us. We can control them. And that was the beginning of that. That was, even though it was a wired remote, and 10 years later, I wouldn't have wanted that as a toy for myself. When I was really little, that was really cool. So I'm going to talk broadly about lots of different kinds of robots and try to ask some questions about how do you distinguish them? Because one of the things that's really hard about robotics is answering the question, what's a robot? So you say a robot is something with sensors and actuators and processing. And then somebody asks, well, isn't that a microwave? And yeah, that's a microwave. That's not a robot. And so you get into this whole debate. It's kind of like the questions with AI. If you can define it, it's no longer AI. Or if you understand it, it's no longer AI. So this is kind of a list that I've been playing with, 10 ways to compare robots. I think there's still 10. Maybe there's 9 now. Anyway, moving versus fixed. So you think about a robot arm. And you think about a mobile robot, they're different. And there's mobile manipulators, but they're kind of rare. Light versus heavy, weak versus strong, indoor versus outdoor. You can segment the classes of robots very strongly along that line. Scripted versus unscripted. There's a lot of robots that just follow a path, just do the same thing over and over. Flying versus grounded. There's all these drones now. Teleop versus autonomous. Uncontrolled versus a structured environment. So that's what Andy was just talking about, where robots for 50 years have been working very productively behind fences in structured environments, and now they're coming out. And finally, a really important one in robotics is demo versus deployment. So when I got back into robotics about 7 years ago at Willow Garage, we looked around and realized that in the robotics community, usually the coin of the realm was videos. So you would go to a conference and say, here's my video. And they'd say, here's my video. My video is cooler than your video. And could I see your robot actually do that? Oh, no. It only worked when I took a lot of video. That's the one you get to see, right? And things have changed a lot over that years. And one of the things that we did over the 6 years that I spent at Willow Garage was focused on building a robust robot, the PR2, that came out of Stanford Robotics Lab, and making it available to lots of robotics labs, and then building the robot operating system on top of that. Also work that started here. And getting that out so that it's now sort of the de facto standard in robotics. And I'll show a little bit of that. This is not going to be a super technical talk, but again, kind of a broad talk. So research and education is one place that robots start. And I mentioned 2 here. These are the 2 that are sort of easiest to buy. right? So there's a lot of robots, and I'll show you a video with a lot of different research robots, and you all know what they look like. There's a lot of 80/20 involved, a lot of wires that you can visibly see. These are 2 robots that are designed, and there's others, but these are 2 robots that were designed to be mobile robots with arms for research. Okay, and the PR2 is the one that, again, the PR1 came out of Stanford and out of Ken Salisbury's lab, and the PR2 was the kind of follow-on generation that I think there's 50 of them in the world now at all kinds of places. They're here, they're at MIT, Berkeley, Stanford, Penn, Georgia Tech, all kinds of places. So this is the PR2 in action, and this is a video that's probably about 4 years old now, showing at the time sort of visualization, how it was building a map. You can see sort of navigation. One of the fundamental rules of robot navigation is just don't hit anything, don't hit anybody. And Willow Garage, there were dents in the walls, but they were from teleop. Not very rare that the robot would hit something while driving itself. You can see there's a lot of visualization tools. The tour de force for the PR2 in the early days, we called it milestone 2, after we got the robot navigating, was getting it to plug itself in. And this is not the right way to charge a robot, right? You should build a dock, right? That's the engineering solution. But if you want to prove that the arms can do a very precise task, this is kind of a cool thing to do. So that was the kind of the beginning of PR2. When we had a working prototype, Peter Abil's group at Berkeley got the robot to fold towels. And this is the kind of how they did it. You get the robot to pick it up by a corner, and then eventually do this. If you want to get a lot of hits on YouTube, which this video did, what you do is this move right coming up here. You just go like this. And like, wow, that's cool. It must be human. It knows to get the things out. So this was a pretty cool thing. This robot took, one of the reporters who reported on it said it could do 25 towels a minute. That was inverted. It did 1 towel every 25 minutes. It's a pretty important difference. And Peter's, I think, gotten that down to under 4 minutes per towel, which is a huge improvement compared to 25, but still not taking anybody who folds towels for a living out of work. And then this was another tour de force at Willow Garage. Once we had the robot and once we had the first version of the robot operating system, we said, can we make it do the thing that all graduate students want, which is to get a beer and take it out of the fridge and bring it to me. They made a little web interface. You told it what kind of beer you wanted. If you pick a Guinness, on the screen, it will pick out the Guinness. If you pick Bud Light, it pops up a dialog box. Are you sure you want Bud Light? So it's a very smart robot. And then it uses the navigation technique. They actually added a little cup holder there. And the cool thing about this was a 1-week project. 1 week, 8 engineers, right? So we take the underlying platform and say, go do this. We did another project, which I won't show the video right now, but it was called Pool Shark, and you can see it on YouTube. And Pool Shark was another 1-week hackathon, get the robot to play pool in a week. And they used an open source pool physics simulator to do that. So pretty cool. This one, they got Coors Light, or Corona, I guess. Corona's okay. And they made a mess. So anyway, that was kind of a cool thing there. So this is all built on software called the Robot Operating System, and you'll see a bunch of, this was a weekend project, get the robot to read MIDI files and play at University of Pennsylvania. And you see just a lot of different robots here. These are KUKA arms on top of a obviously homemade base. These are early drones at the University of Pennsylvania doing some cool things inside of a motion capture system so that they could get position. This is here at Stanford. Morgan Quigley's building a robot arm. This is that Now robot I mentioned earlier, but using ROS to navigate. Dancing with a robot out of Germany called the Carabot. This is out of Zurich, robots that go through pipes. What's interesting and what's common about all this is an autonomous car. All of these robots are running ROS, or some parts of ROS. And I say some parts of ROS because this is obviously not exactly your typical robot. They're using an accelerometer on the board and using all the ROS tools to visualize it in 3D. This is a TurtleBot, sort of the lowest cost ROS robot that we built at the time. This is Lego Mindstorms, but you had to run the ROS on a separate computer, not on board. And this is a robot at Georgia Tech. So you get the idea. There's a lot of research robots. They look a lot different. And what's cool is that this robot operating system works on a lot of them. So what this means in terms of the point today is that robots are coming online and becoming available commercially for the first time around people. And it's not that there haven't been any, but there haven't been very many. And I think that's due to technical enablers. The ROS, free software that lets you get started. So we're, Savioke, I'll fast forward a little bit. Savioke is now 16 people. We started as 7 people. We've been in business for 15 months. We've got a robot in the field and 2 more. We built hardware, we had software, we got the thing working in a year, right? We were in 10 months at the first deployment. That's incredibly fast, and that's due to ROS, right? That's due to the fact that we can start with a working code base and improve the parts that need to be improved. It's also due, and robots coming down in price is another reason that they're going to be available. The PR2 would be cool. You could have it deliver beers in restaurants. It'd be awesome. At $280,000 a pop, it takes a lot of creativity to justify how you're going to make money at that in a restaurant. And then cheap sensors is a big deal. We built the PR2. We put a stereo head and a structured light, sort of projector that put out a light pattern, so you could actually do essentially what the Kinect does. But we built that custom. That was probably a $4,000, $5,000 BOM part of the robot, very expensive. The Kinect came out for $150, right? And they sold millions and millions of them. That's the good news. The bad news is Apple bought PrimeSense, which makes the Kinect, and so they're not as easy to find now. But the technology is coming to the point where it's now consumer products, right? And one of the things I sometimes say is that robotics is the poor stepchild of every other industry, right? Every other industry has volume, and to date, robotics really doesn't have much volume, with the probably notable exception of iRobot, who's got a lot of Roombas in the world, I think 10 or 12 million. This is probably the best thing that came out of Willow Garage in terms of the robot. So people ask all the time, what's this robot for? And this is a man named Henry Evans who called us up and said, I saw your robot on CNN, and I think it could be my external body. Henry was a CFO of a Silicon Valley company, had a brainstem stroke about 11 years ago now. And he just called us up. He types using his head on a keyboard, or he can use that board that he uses to speak to his wife. But here's the clip that he saw on CNN, and he said, hey, can I get access to one of those? And so we started this project called Robots for Humanity, and this is the interface that was built. He actually used PowerPoint to draw an interface, said this is how I want to work it, and then sent us that. We sent it to a Georgia Tech grad student who built the interface to control the robot, and then Henry went and used it. The first thing he did with the robot was turn it on himself, as you can see here. And this is a recreation. The first time he didn't have anything in the robot's hand. He put the hand right in front of his face, and we're like holding the run stop. What's he going to do? And he scratched an itch on his nose, right? It's like, it was the most touching moment. Then we said, well, what else do you want to do with the robot? And he said, I want to shave myself. And so we actually, you can see here, there's a force torque sensor attached to kind of a razor head. That force torque sensor tells you how hard he's pushing. And so we had his wife shave him the way she normally does, and he shaved himself. He pushes 10 times harder, right? So no wonder he wanted to shave himself, right? But it's also just about his dignity and being able to do things for himself. So this is him using the robot from a distance. So he's in one room. He cannot see the robot now. His eye's off. He's in another room. The robot's opening a drawer. He's watching it. He's watching through video feeds. And he's using it as essentially a remote body. And later we took this robot to his house. He drove it across his home, opened a drawer, took out a towel, brought it back, and used it to wipe his face, right? So imagine for somebody who's mute and quadriplegic, who can't basically do anything with the world except for move his head around, suddenly he's able to affect things. There was a clip just there of him handing out candy to trick-or-treaters. We did a thing here at Stanford Shopping Center. So this is a project that, as you can tell, I'm passionate about and drives me. One of the first things we did when we started Savioke, as we were exploring what was our project going to be, we funded a project at the University of Pennsylvania, and they built this robot called ScratchBot. They didn't call it ScratchBot. Henry calls it ScratchBot, so I use that name. This is a carbon fiber robot arm, very lightweight, counterbalanced, designed to be something that's not going to kill him while we're not looking. It's an important feature. And he uses it basically to scratch his itch. And it's mounted to his table. As you can see, this is his bed at home. And he uses it basically every day he estimates he gets an itch 20 times an hour, something like that. So you can imagine how long you can wait before you just want to scratch. And he has, some signal with his eyes that he uses for his wife to scratch, but it's, it's not a favorite thing to have to ask for that. He's much happier doing it himself. And you can see he really goes at it. He's a very funny guy. He has a TED Talk where he talks about his disability, if you're interested. And he made a point to say on the TED Talk that he routinely beats his friend Steve Cousins at Word with Friends. So I really appreciated that. Henry, thanks. So let me step back and talk about other robots. Now, what are the most prevalent robots in the world? There used to be 10 million Roombas. I think there's more like 12 million iRobot Roombas, and then there's a lot of knockoff vacuum cleaning robots. It's a pretty good idea, right? So there's a lot of vacuum cleaners in the world. They have a characteristic that almost all of them are, or the Roomba in particular, is random, right? Sort of doing a random walk. It's got some algorithms inside to make sure that it's going to get coverage statistically over time. It doesn't make nice, neat rows. Competitors like the Nito vacuum out of from around here can go in nice, neat rows using some cool technology and low-cost lasers. I don't know that they've sold quite as well, but there's a lot of vacuum cleaning robots. That's the only, besides pool sweeps, I guess, that's the only real home robot that's taken off, right? And we did a study at Willow. We asked people, what do you want in a home robot? And they were very clear. I want it to do my laundry. I want it to do the dishes. I want it to do my homework, right? So the third one, you can see why that may not be a good idea. You could just excuse the homework. That would be easier.
Grade the homework.
A lot easier. You could grade the homework. The second one, doing the dishes, you have a dishwasher, right? And so there's something that you want, but it's not just doing the dishes. What you really want is someone to clean up the kitchen beside the dishwashing part, right? Or you want somebody to do the pot scrubber or something like that. The laundry, you have a washer and a dryer. So it's not that you want it to stop you from having to go down to the rock by the river. That's not the point. The point is I want it to take my dirty clothes from the hamper, put them into the washer, move it into the dryer, take it out of the dryer, fold them, and put them away. That's the rest of the laundry task. Those are really, really hard tasks for a robot. PR2, we tried to have the robot just empty the dishwasher. It's a simple task. And you have to have a certain sense of feel. If you grab a dish, like a plate in a dishwasher, and you pull up on it, what happens? The rack comes, right? You automatically move it, wiggle it. If you don't wiggle it, it's not coming out, right? And so there's a pretty complicated manipulation that's required just to do simple emptying the dishwasher. And you've got to be pretty strong, right? And you've got to have a pretty good reach. The PR2 was designed, it's like about this tall, right? It's designed to go taller and shorter so that it could reach the ground. It's got these kind of gorilla arms. And still, it can't, because it doesn't have a waist, right? It's only got its arms. It's like you try to put your dishes away while you stand straight up, or if you have a back problem. It's going to be really hard to reach that cabinet, right? So it turns out home robotics is really hard. On the other side, factories. There's only about 2 million factory robots. They're incredibly productive, right? You don't really want to drive in a car that wasn't built with a welding robot because they don't miss any welds, right? Everything gets done where you want. They weren't made on Monday morning, if you can imagine that scenario. And so factory robots have been really, really popular, and they've been behind fences. Telepresence robots are really popular. And I'll tell you a quick story about, at Willow, we built a telepresence robot called the Texi. It was named that because there was a guy named Dallas who lived in Indiana. He was a great engineer, and we wanted to hire him. And Dallas got frustrated with sort of the Polycom in the middle of the table, and so he said, can I get a laptop and Skype? And so we got him a laptop and Skype, and we put it at the end of the table, and then he complained that he couldn't see the screen very well with the little camera. Could we get him a better camera, and could we get him a camera that he could turn and look around? And we kept on making it better to try to bring him more into the picture. All this time, I wasn't in those meetings. This was kind of the double E team meetings at Willow. So I barely know this guy. All I know is, as the CEO of Willow, I have to pay taxes in Indiana, right? So I know he exists, but otherwise I don't know him very well. Suddenly, they come on this plan where they've now evolved this laptop into a desktop computer with a big screen, with a nice camera that can move around, and they put it on a cart with an uninterruptible power supply so that they can push it into the lab without turning it off. And then they went, wait a minute, we're a robotics company, right? We can do better than this. And they took the caster from the PR2. We had done a rev on the casters to make them quieter. They took a noisy caster and they attached it to the bottom of this frame. And suddenly Dallas, with a joystick, can drive down the hall in this kind of contraption. It was totally life-altering, right? Because suddenly I would walk down the hall, and there's Dallas rolling down the hall, right, with his face on the screen. And I'd go, hey, Dallas, and I'd go, hey, Steve, and we'd just pass, right? It's like, you start to know that this person exists. You know, he could come to lunch. He couldn't eat, but he could come to lunch and at least converse with people. So that robot became the tech side, and it became the Suitable Beam. So if you know the Beam, Dallas is working for Suitable. Scott Hassan, who founded and funded Willow, is now running Suitable. And they produced this thing called the Beam, which is this middle robot here. There's a lot of robots in this telepresence space. Eric Schmidt once explained to me why telepresence was so important to him. He said, I have all the travel amenities known to man. I have my own jet. I can fly my own jet. I can go first class. I can stay in the nicest hotels, but travel's still killing me. But with something like this, I can avoid the trip, and that's a big deal. Right now, we're not all Eric Schmidt, but it is very nice to be able to set up work groups where you have remote participants this way. And at Willow, we had 4 beams and people working all around the world, and it does work. If you come into if you have a meeting, this room's okay because we have this side, but if you have a way for the beam to come in, you get into the next generation of problems, which is like, where should I park the beam? It's nice to be in the front row, but then nobody behind you can see, things like that. The other ones here, the iRobot, Ava is they're working with InTouch Health, so they're using these in hospitals as a RoboDoc. And there are apparently some hospitals that are RoboDoc only at night. So there's, you can get a specialist, but you're not going to get the only kid if you're in a remote hospital, you're not going to get the only kid in that specialty who would, like the last job you could get, right? You're going to get the best person from wherever calling in because they can do that and they can moonlight, or maybe they're even daytime for them. And Double is in this space. Double is interesting because it's self-balancing, one, so that's kind of interesting and scary. And also it's very cheap. It's on $2,000, so that was a really interesting price point, and they've done very well. Another class of robots, I'm talking about kind of as robots are moving into the service industry, and there's this another class called kiosk. I'm calling them kiosk bots. I don't think they call themselves that, but maybe it'll catch on. And one of them is called Pepper. Pepper is a robot actually out of France. So there's a company called Aldebaran, and I'll show you. Well, I showed you the now earlier, and unfortunately I have a clip for this, but I have to be on the network, and I'm not. So, but you can look up Pepper on YouTube and see a video of it. What's interesting about Pepper is that it moves very gracefully. It's got hands, but it doesn't really hold anything. It's not designed to pick things up and manipulate them. It's designed to be a kiosk, right? Sort of stand there and greet you when you come into a store. Osh, the Orchard Supply Hardware, which is part of Lowe's, has introduced the OshBot, which is similar. It's got a tablet on the front and a tablet on the back, so it can advertise all the time, no matter which way you're facing, I guess. And you can interact with it, and they're working on various AI techniques to let you do interaction and find things in the store.
How big is it?
Which one?
The robot that moves so gracefully.
The Pepper, or I think it's like this big. I actually haven't seen one in person yet. I know that now is like stands on the desk. It's about this tall, and then the Pepper's like this, and then they're building one that's bigger. So Aldebaran's run by a guy named Bruno Massanier, and Bruno is very big into humanoid robots and believes that robots should be social. And there's definitely a school of thought, and I think it's not universal, but there's a school of thought that making robots more social, making them more humanoid, is a good thing in some way. And there's also a school of thought, which is closer to where I am, which is that you make robots useful, and if you make them too close to humans, it gets kind of freaky. And so I think there's going to be time will tell which ones are more popular, which ones get adopted. I can tell you that the cost of the robot goes with the number of degrees of freedom, number of motors, and so if you go with a robot that's simple, you save some money. And then there's this category of delivery bots. The delivery bots have been around in small quantities in hospitals for about 10 years now, maybe 12 years now. The Aethon Tug on the left here is sort of the classic there. And then a company called Vecna announced one 3 or 4 years ago. We've built, and I'll show you more about it, the Savvy One, which is a robot that's designed to be smaller, to basically more nimble, smaller loads, and really operate around people. Where some of the bigger robots, if they do ride an elevator in a big building, insist on going in by themselves. So basically, I'm not going to get in unless it's empty, or I'm going to clear out the car, sort of satisfy all the car calls before I get in. We just get in the car with people if there's space, right? And take advantage of the fact that the robot's round so that it can spin in place and face the door. So I'm going to dive in a little bit and talk about Savvy One, also known as the Butler. We're working with Starwood, and we've actually, since August, have had a robot in the field. It's done about 1,400 deliveries, 400 of those actual to guests, and another 1,000 kind of test runs up and down the elevator. And about, we just crossed last week 100 miles of indoor travel. So it's coming along, the first one, and we're about to go into 2 more hotels. So it's a pretty exciting time and kind of is growing. But this is kind of where it came from. And again, this is where we started. I think this picture was shot sometime early this summer, like around May probably. And what you see is a whole bunch of robots that look like junk, right? Foam core, little frames. That's how we prototype. So we built a prototype that was basically a Roomba or iRobot Create with some sensors on it. Said, can we get the basic software turning over here? Just put some processor. We built a bigger one. We put a foam core that's about the height that we want it to be. We mount the sensors up high. Let's test that one. We built this frame. The frame is cool. You take a piece of MDF 4x4, take it to a laser cutting shop with the right pattern. They give you a bunch of pieces back. You glue them together. You have a frame. You put it on top of a base. We had this problem of, well, we want to try this thing out in the field as soon as possible. How are we going to dress it up? And so I suggested spandex. And we tried it. Adrian Canoso is a sport and our industrial designer, and he wrapped it in spandex and took the picture, and then he ripped it off. So we got rid of the spandex and did this. Now this is interesting. How do you make this nice plastic cover in quantity 1 for not too much money in a startup budget? This was before we had our seed money. And the answer is you get a 3D printer and you print lots of little pieces, but you've designed them with CAD so that they all glue together and go on the frame. And then we learned another cool trick, which is you take that robot that you've built and then you give it to an auto body finisher, and they make it look really pretty. So it's a pretty nice prototyping technique that we use to get the first version working. So this is what came out of it. Oops. I don't know if you can hear. This is a video that Aloft made, Starwood made for us. It's a little bit rock music-ish, I guess. It's actually not that different from the experience at the Aloft. It's actually like fluorescent lights in the elevator. It's kind of a weird place. But the robot, in a nutshell, you call the front desk, you say, I want a water, could you send me up a sandwich? And they basically charge it to your room, put it in the robot, type in your room number, and the robot shows up at your door, calls your room, you answer the phone and open the door. And then there's a very cool locking mechanism. When the robot's lid is locked when it's sitting there, and then when you open your door, it sees the door open, so then it opens its lid, right? So then you get it safely and securely without having to do a PIN code or some biometrics or whatever. So this is the Savvy One. It's here. And I'll just give you a very quick demo. So as I said, imagine I'm the front desk agent. Somebody calls me up. The robot's sitting here in its dock saying, hello, I'm ready to deliver. So I have to enter a passcode. And then I have to enter a room number. And I think I put room 100 in this room. Room 100 is simulated. It's over there. And so then I say load. So the passcode is to keep the 9-year-olds from sending it around the hotel if they get a hold of it. And the room number is sort of the minimal level of interaction that you need to specify a location, right? And it's sort of easy to use. So I say load, and it opens up, and there's a little bin in here. Actually, in the current version, this is sort of the road version, but in the version that's in the hotel, we've redone the bin so that it's about this deep. So you can hold basically 2 feet by 1 feet by 1 feet of stuff. And then there's a little tray that sits inside so that when you put a toothbrush or toothpaste or typical things, they sit up high so the person doesn't have to reach down deep. So if you take the deep bin, you put a bag in typically and pull it out. So I load it up. I'll put my pen in there. It's not like a magic trick. It'll still be there when it gets to the other side. I say go. And now it says I'm running a delivery, makes a little cute noise, and starts going to its location. If you're a 9-year-old, you can do this and sort of keep blocking it. If I keep doing that, it'll try to find another way around. It sees that it can't go there. And now it tries again. And I messed it up now because this is kind of a small space. But it'll replan and then say, all right, now I can get through. And this, as I say, works very reliably in the hotel. Pretty simple idea. It's is it artificial intelligence? Well, it's artificial intelligence from the 80s, right? We had planning algorithms and search algorithms. It's not conscious, I'm pretty sure. Hasn't been hit by lightning, so therefore. And I take my pen out. It says, please remove your items. I say, all set. It asks, how did I do? If I give it 5 stars, I get a happy dance. It's always a nice little thing. And then it automatically, it's actually delaying right now. The delay is artificial because when our initial user testing, we found people didn't like the fact that it just left. Like, I want to interact with it. I want to take a selfie. And so we take it for another 10 seconds before it leaves. Then it goes back to its dock and resets. So that's sort of what it does. It's, yes, incredibly simple, right? I can't believe I'm at an electrical engineering seminar talking about such a simple thing. But it's also, because it's so simple, we can work on the next hard thing, which is all the corner cases you have to deal with in unstructured environments, right? How do you get the algorithm so that, when it shows up in the elevator and there's people in the elevator or there's a big cart in the elevator, that it does the right thing? How do you handle those cases? I'll tell you, this is a true story. I was watching the robot one evening, and I was sort of just following it kind of as a safety driver, but not interacting, right? Just it's doing its thing. And here's the elevator, and the robot comes around, and in the back of the elevator is this little girl with her suitcase. She just checked in, and her mother's there, and she's standing there with her mother, and the robot comes, it's starting to come in the door, and the girl goes, like a robot, and she runs up to it, and she's like this. She's like petting its face, right? So the robot naturally is not going to run her over. That's good. But it's now, she's standing in the door of the elevator, and the robot's standing outside, and she's blocked its path. So she's playing with it, doing whatever she's doing, and finally her mother says, let the robot get in, dear. She pulls her back by her shoulders, and the robot starts to get in, and it gets halfway through the elevator door, and the girl runs up to it again and starts playing with it. So now it's in the elevator door. Fortunately, it's holding the door remotely, so it's not going to close on her or the girl, on the robot or the girl. And now somebody from the bar who's been drinking comes around, sees an elevator in the door of sees a robot in the door of the elevator, like, oh, this is holding up the works. I can fix this. Kicks it, and he kicks it again, and he shoves it into the elevator. And the robot, fortunately, doesn't have a temper or anything, so it just, what?
I think you could put one in.
We could put one in, yeah. We've talked about,
We have the technology.
yeah, we have all kinds of robot self-defense ideas. But in this case, the Martin Luther King approach works. You just push it in, and then the robot turns around, faces the door, releases the door, rises up to its floor, and goes on and does its delivery, right? So it takes a lot of engineering to get that kind of behavior to work, right? And I can't promise it's going to help with everything that anyone in a bachelor party happens to think of, but I think we've done a pretty good job of thinking through some of those cases. So that's Savvy one.
You don't have a remote operator to do the debugging?
So in terms of like the phases of the project, in the first phase of the project, somebody from Savioke always follows the robot. That was until Thanksgiving. Then the hotel was complaining because a small company, we can't follow 24/7, so it's not available all the time. So then we came to an agreement. Their staff will follow the robot, and we'll just monitor remotely. And that's the phase that we're in now. And then the next phase will be one where the robot's going on its own. We're still monitoring it remotely. And we'll always have the ability to help it out remotely if it gets into trouble. There are cases that are very hard to deal with or impossible to deal with. So there's a hallway and at the end of the hallway is the room you're trying to deliver to, and in the middle of the hallway there's a laundry or a housekeeping cart that's parked, taking up too much space, right? You simply can't get by. A person could get by, a person could move the cart. This robot isn't going to move the cart, right? We're not even going to try. And so we have to get help at that point, or at least we have to let the hotel staff know that this delivery, we don't know what it is, it might be ice cream melting, right? This delivery it's supposed to be there within 15 minutes, it's now been 10 minutes and our path is blocked. So those are the kind of logic that goes into taking care of those cases. And this is kind of another example of kind of delight. I just was following the robot and I caught this girl. She saw the robot and she just started following it, like all the way down. At some point she looks back at me and goes like, why are you watching me? You know, like, well, it's just so cute with that party dress following the robot. I just couldn't resist. The hotel spent a lot of time, they moved it. So when we first put it in, we're thinking this is all about helping them send deliveries more efficiently. So there's a front desk at the loft. It's round, and there's like an opening at the back. And so when you come in the front door, it's like over there, and you come to the front desk. We parked the robot back here along this wall. You saw how I parked it over there, and it's kind of subtle, and you don't really notice it. Well, the same thing. It's behind the desk. Nobody noticed it, and the hotel management started to get upset. Like, nobody's noticing the robot. So let's move it out. So we changed the docking post so that now the front desk has to walk all the way around, like out by the front door. That's where they want to park it. But it's very visible to everybody in the hotel. And they parked it right in front of they have this tower of lit up blocks called, let's say, a loft all over them. And right in front of that, they put this sticker, this Bottler parking sticker. And so the robot always parks on top of that sticker now. And then it says, snap a selfie. And you snap a selfie with the robot, you get the aloft blocks in the background. Very clever for them. So, so anyway, I would say we totally underestimated the value of the delight part of the robot, right? So we designed it for utility, for return on investment, and kind of keeping the cost down and making sure everything was valuable. But Starwood is, they did that video that I showed you, and a whole marketing campaign around it, and had something like 1.3 billion media impressions in the first month. So it's pretty good at capturing people's imagination. I think what Andy said earlier, it's really about somehow robots just capture your imagination. And I'm a software guy. I came out of computer science here, but what I found is whenever I'm talking about robots, people don't care about the software. They look at the robot. Look, what it does is interesting, but what's underneath, people don't care as much about. So it's much easier to show. I can show you videos of all kinds of robots using ROS, but showing you video of ROS would be really boring. Except for the animations, I guess. There's lots more robots, and I won't. I'm going to save some time for questions, so I won't go through all of them. But drones, obviously, huge right now. That's the Amazon drone. Google has a drone as well, and there's 3D robotics doing drones for agriculture. The Google car we've already talked about a little bit, and this security robot called Nightscope that's come out, and I could go on for a long time talking about lots of different robots that are out there. But instead, what I thought I would do is take these as examples and go back to my first list of how you distinguish robots and see how they kind of fit. So back to the 10 ways to compare robots, and let's just go through them one at a time. So moving versus fixed. Most robots, when you think about industrial robots, they're fixed. But most of the robots that we talk about and that are coming up now are mobile. So that seems to be a characteristic that's pretty important of a robot. Would rule out the microwave and the dishwasher and things. The Scratchbot and the industrial robot arms obviously are fixed. And there's, as you know, a category of industrial robot arms that are safe enough not to have to go behind a cage that are Baxter and Universal Robotics that are coming out. And so I think that space is moving in an interesting direction. Light versus heavy. So I moved the PR2 down, and the heavier delivery robots that can bring 500 pounds. That's a big robot. This robot I left kind of at the top, but this would be the most heavy robot up there at about 100 pounds. So and probably not necessary to be quite 100 pounds, although there's an interesting trade-off about the lighter you get, the easier it is to steal. So the 100 pounds, you kind of want two people to carry it. You what?
No countermeasures?
Yeah, there are, but they're secret.
Acid batteries.
Actually, we do. Well, we did. It turns out lead-acid batteries have the wrong characteristics in terms of number of recharge cycles. So that's a really important piece. You want to put a robot out in the field for years, and you don't want to have to be replacing the battery every quarter. So we tried lead-acid. We contributed more than our share to landfill, and we stopped using them. So we moved to a different chemistry. But it's not lithium-ion for that reason. You pick a chemistry in the middle that's more heavy because we don't need the weight. We don't need the low weight. We actually want weight. In fact, this battery, I think, there's a block of steel about this big next to the battery just to make up for the difference from lead acid. Weak versus strong. You might be surprised when I put the PR2 on the top, but PR2 was designed to be safe around people, and so the amount of payload that its arms can lift is actually very small. So in spite of the fact that it weighs 500 pounds, it can't lift more than about 10 pounds. Obviously, drones, you could imagine a drone that could lift a lot, but you can't imagine it landing in your yard safely. And so most of the robots here end up being weak. I think as I'm talking about service robots coming forward, it's sort of an interesting characteristic that weaker robots around people is a sort of necessary thing. So the question is, what can you do if you're weak to actually help people out? Or how can you be strong and yet safe? Indoor versus outdoor is also an interesting way to cut them. I brought back the 3 outdoor robots. Most of the service robots are designed for indoors, and that turns out to be a nice simplifying assumption. It's not just so easy as making it waterproof or snowproof. I mean, imagine an outdoor robot on the East Coast right now. You might be struggling. Actually, imagine the Google car on the East Coast right now. It would not be driving. But the one thing is that the sensors that are designed for video games that get the high volume are typically putting an infrared pattern out, eye safe, therefore not very powerful. And when you put them in the sun, the pattern gets totally washed out. Just think about the white balance on your camera when you go outside after it's been inside. And so there really is, it's hard to imagine, it's not impossible, but it's hard to imagine a robot that's cost effective that goes both indoors and outdoors. You'd have to design for that. You wouldn't come upon that accidentally. Scripted versus unscripted. So the 2 in the corner just are teleop, so they don't really count for either. But this one's a little bit of a vaguer category. So when I start talking about the Pepper and the Now and even the Aethon Tug, those robots, you can program them. They can do some things autonomously, but they're typically scripted, right? So the Now is, it's all about programming. You pose it into different poses, then you have it do a dance. On the unscripted side, that's really the AI planning navigation, right? So you're giving it a goal. Like this, when we came in here at the beginning of this, just before the talk started, I just drove the robot around and built a map, right? I never told it follow this path to get there. I just said, this is the location, go there, and then it comes on its own, right? So it's not, again, not conscious, but not scripted either. And then flying versus grounded is easy. I thought about filling the sky here with lots of different drones, but you get the idea. And then teleop versus autonomous. So you saw when Henry used the PR2, Henry Evans, the quadriplegic, used the PR2, he's using it in the teleop mode, right? Actually, he's using what we called assisted teleop or supervised autonomy. He's doing something, but he's having the robot help him do it as well, right? And a good example of that, when Henry wants to shave, the first version, he had Cartesian controls. So, all right, so you move the razor up, down, left, right, and you know, he brings it over. But now you have to angle it. There's 6 degrees of freedom that you need, right? And it's not easy to sort of think in 3D when you're facing the other way and get this thing done.
How long it take for him to get frustrated?
He's got amazing patience. You think about living with what he's living for 10 years. He's got amazing patience. But what we did was the Georgia Tech students modeled his head as an ovoid and then said, OK, given that, when you click in the picture, let me calculate the normal to that, right? This is something that's real easy for robotics people. Just, OK, take the normal. Now I'm going to just bring in the robot there. I'm going to stop 1 centimeter from the surface. And now Henry can just reach over and scratch, and he gets it exactly the right place, right? So a little bit of programming, a little bit of intelligence, human intelligence, to build really clever models makes a big difference in terms of how the robots can be used. finally, uncontrolled versus structured environments. I think that's obviously for the service industry. You can do things. There have been robots for probably 20 years that are doing mail delivery in offices, but they're following a trail. I mean, literally a trail. They have special ink that they'll put on carpet that it's invisible, but the robot can see it, and it'll just follow that, just line following, basically. The problem with that approach is, of course, when somebody puts a box down in the middle of the path, the robot just stops until somebody moves the box. And so it's nicer to sort of really operate in that unstructured environment. And it's relatively straightforward to model it. The problem of I mentioned at the beginning, the problem of navigating mobile robots, wasn't really solved in 1994 when I was here. In 1999, using LiDARs, Sebastian Thrun, who came here later and won the DARPA Grand Challenge for Stanford, when he was at CMU, that was his thesis, was basically solving navigation using LiDAR. So that's a problem that's been now academically solved for 15 years, right? And one of the questions we asked ourselves 15 months ago was, if that's a solved problem, how come we're not seeing very many robots out in the world using it? And so that's where we set out to do. And then finally, this is probably the most important one, is demo versus deployment. So that scenario I talked about at the beginning of you make a video and you compare my video to your video, or I have a demo and you can see my demo, but there's a real big difference, as you know, between building something to demo once and trying to put something out and leave it in the field. But I think a lot of people are trying that, right? So I would put the Amazon drone in the demo category, right? I think they're a long way from actually delivering things with it. I moved the Scratchbot down a little bit. It's deployed in one user. It's not a business, but there's one of them. The Google car, probably there's a lot more Google cars in the world than there are PR2s, but the difference is you could buy a PR2. You can't buy a Google car today. So I moved that one a little bit lower. And the same thing with the Now. I think there's over a couple thousand Nows in the world now. They're on their second generation. And then the ones in the bottom are available for sale and used more or less widely. The Pepper robot, they're making 10,000 of this year, which is starting to be a significant number. And apparently they've got orders for 100,000 in the next few years, next 3 years. So that's, I talked about at the beginning, millions of robots, right? There's 12 or 14 million robots in the world. If you can make 100,000, you can at least be one decimal point, right? Until you get to 100,000, it's not that, you haven't really made a mark, right? That's where we're heading to, we hope. So with that, let me stop and just take any questions you might have. Yes?
Why don't they have it come to the desk and get the stuff, then head off? Why do they walk out to?
That's coming. That's coming very soon. The technical reason is that in order to do that, I have to integrate with their desk systems, or I have to put a tablet on their desk, and then I have to secure it, and I just haven't. So we built this very simple standalone system that just does its thing, and now there's like one more piece of it, the thing that lets me call it, that we just have to put in. But yeah, conceptually, that's near on the agenda. Yes.
What's acceptable in terms of how long it will operate on a single battery charge?
So it turns out it's not about how long it'll operate on a single battery charge. It's how fast you can recharge it, right? That's what matters. So this battery technology, we can recharge it twice as fast as it discharges.
Why don't you swap the batteries? I mean, that's an old electric car solution that nobody...
So we asked this one, and the reason is, I asked this one, and the reason is that the battery needs to be low and in the middle, and it's really inconvenient to get to it.
No, you push it through. You have an input port and output port, push it through. That's what they did for the cars.
Yeah. It's interesting, but
cars even can drive over it and do it. You don't have to stop. Input, output.
All right, well, maybe for the next generation.
But just out of curiosity, so duration of running versus duration of charging?
So it charges twice as fast as it runs, which means that if I charge it 20 minutes out of every hour, it'll run it all the time. It'll run 24/7, right? So what that means is at the Aloft in Cupertino where it's deployed, the average delivery is about 7 minutes. So that means I can do 5.5 deliveries an hour, 24/7, right? But it can run for, I think, 4 hours without any charge. And so really what happens is if you got to the busy time where you were having 10 deliveries an hour, which is about, you can't do 10, you could do 9, right? If you're getting 8 or 9 deliveries an hour, yeah, the battery will run down, but hopefully you don't going to do that. Well, actually, I hope you do need to do that sustained. If you actually use this robot enough that you need, that's a problem, then you need another robot. That's good for me. Right. Yes.
I'm still puzzled. Why don't you put the battery at the bottom of your frame? Then you deliver and get batteries. That's the same process.
No, it's way lower, right? The tray only goes into
Put
here.
it on the bottom of the.
Anyway.
Sorry, I've been there, done that.
All right.
Being frustrated by it. Sorry. It is. I don't think it's such a big deal.
Okay. But
It's a conceptual deal.
I will pass that on to the mechanical engineering team.
As I said, we have the same story with electric cars.
Yeah.
Have you thought of,
And there's precisely 4 electric cars with 2 batteries swap.
Lift it up.
I won't get started.
have you thought about voice interaction with the robot?
Yeah, we've thought about it. We haven't done that for a couple reasons. One thing is there's 2 parts to it, right? You can have the robot speak, and as opposed to doing the little beeps and whistles like R2-D2 that it does now, and you can try to do voice recognition, right? So having the robot speak without doing voice recognition sets expectations up here, right? And our philosophy is we keep the expectations low and we try to overachieve instead of not achieving. In terms of speech there, the Now, actually the new generation of the Now is doing word spotting to try to do this, but that's as well as they can do. So they've got voice speech recognition, they're trying to do word spotting using nuance technology. When you actually use this, you're in a noisy environment, like the lobby is not an ideal place to be talking to it. And so we just, the complexity of trying to get a microphone array so that you can do speaker location detection and then focus there and do all that stuff. That's a research project, right? We didn't feel like that was something we could deploy in a year robustly, and so it's not in the first version. Yeah. Yes. What are you doing? Go on.
Well, no, I was going to ask the same question about the voice interface. I was going to ask about first-time users, even with a nice clean interface, may feel a little bit not sure what's happening here when something knocks at the door. Would there be an open microphone speaker channel to the front desk so that...
So we've talked about doing that. We did a lot of user testing early on once we had the robot. What we're happy to find out is that nobody seems to have trouble using it, right? This thing shows up, it says, here's your delivery, and the lid opens. You asked for it, and the lid opens, and so taking it out turns out to be pretty easy. And then we've got the fail-safe. So sometimes people don't complete the interaction, they just close the door. And so then the robot waits a while, and then it times out and goes back. I first thought that should be like a 10, 15-second timeout. And we didn't implement it. We hadn't hit it like either 2 minutes or we hadn't implemented it yet. And the first time we saw this, the guy opened the door, and we're like kind of listening, following the robot, but hiding around the corner so we don't mess with the interaction. And we hear the door open, and then we hear the door close. Like, what? What happened? And now, like, what's it going to do? Do we need to go get it? Is it stuck outside his door? What's happening? I don't remember if the timeout was implemented yet. We had talked about it. So we're like talking about what should we do? And then 45 seconds later, the door opens again, and the guy comes back with his cell phone. He's taking pictures, right? So that's sort of the more typical interaction. So we've left it, I think, at about 1 or 2 minute timeout now. So just but yeah. We haven't had any problems of people like not figuring out how to get their stuff from it. It's pretty obvious.
Are you doing remote monitoring then?
Yeah.
In the early phases?
Yeah.
Because a typical thing to do is have what I call a human-human computer interface.
Yeah.
I mean, early monitoring phase, and then
so
improvements and.
So our phases were we follow it, staff follows it with us monitoring. That allows us to debug the monitoring tools, and then it'll go by itself with monitoring, and then eventually it'll be more loosely monitored, so it'll only raise a flag when it notices there's a problem. We have a pretty good task model at this point of the steps of the robot and how long they take. So we can use that to say how long before I raise a yellow flag, and then somebody looks through the camera and sees that there's some kids trying to keep it from getting to the elevator, then you decide what you're going to do, right? Taser or no, I'm kidding. Yes.
Any thoughts on climbing stairs or other obstacles?
Yeah, it goes downstairs once. No, it's actually we've thought about it, but that adds a lot of complexity to the robot. It turns out there is actually a pretty robust way to get upstairs and downstairs, which is to use a tread. It's just really hard on the stairs, right? And so, and it doesn't really work in hotels because if you're going to do that, you also have to do fire doors, right? Hotels have this. Not all. I mean, there's very few Grand Budapests, right? So most of the hotels have fire corridors around the staircases. So you go in, they're always concrete and ugly and stuff, and they don't want you to go there. And they all have fire doors. So it's only there for emergencies. So we actually, when we did the safety analysis, we said, well, what could go wrong with this robot? And one of the things was, well, what if it falls down the stairs? Because it's like 100 pounds and it could hurt somebody. It turns out at almost all hotels, and all hotels that we'll go into, they have the fire doors, and there's a bar, and we got lucky because the bar is this high, right? So we can't actually trigger it. And I mean, then there's like N failures before you get to that point, right? It has to be confused about where it is. Get the bumpers, a bumper on the front that if it's never supposed to hit anything, but if it does hit something, the motors lock out. So all these things have to fail for it to fall down the stairs.
If it follows the crowd in an emergency, then gets out.
Yeah, well, I mean, you could imagine that that's one of those cases. Yeah.
What's the language you're using to program?
So we use a combination of, at the core, the raw stuff is mostly in C and C++. There's a good interfaces in ROS for Python, so you can script it, and we use that for a lot of tools and like test tools and that sort of thing. And then the user interface is all done in JavaScript. So it's actually all a web app. So I could run that same, what you're seeing on the screen, I could run on my laptop. And that's a really nice feature because it allows us to build interfaces in the same way that we can deploy in lots of, the sort of classic web thing, right? Yeah. Yes.
Were there any big surprises in user testing?
I think that, well, one of the big surprises was that they wanted it to stay at the doorway longer. Right? We thought, like, again, we had this whole thing about efficiency, like it's get in, get out. But that's not what they wanted. The guests seem to want to spend more time with it. And if they don't want to spend time, they can just close the door on it. I think, yeah, that's probably the biggest one. I mean, I told you the story about the drunk guy.
Doorman version of that always stays
there. Yeah, just stands there?
Yeah.
Yeah. Well, it's easy to make a robot that doesn't move.
My friend is coming to do the delivery for you.
Yeah. Yes.
What are your thoughts on these kind of robots in senior care homes, particularly with regards to the user interface?
So I think that so we've done in the next generation of the hardware, we've slanted the tablet back a little bit more so that it's easier to reach over it if you're in a wheelchair. So I think this robot is close to doing one thing in senior facilities, in elder care. It'll do the same thing. It'll do delivery, right? It doesn't solve, there's a myriad of things that robots could help with in elder care. There's people, working on it and research all over the place. It's not going to solve loneliness, it's a lot of classic problems. But what it does do in that direction is it can take a load off of the staff and let them spend more time with the residents, right? And so that's the way that we think about the value of this robot there. Take a load off the staff, and then the
bean counters will fix that.
The bean counters may fix that, but that's their option, right? And we do the same thing actually in the hotel when we talk about what value it brings. A lot of the value is in letting you rework the process of the hotel in order to do things more efficiently and potentially to add services back. Because one of the problems that hotels have is labor costs go up, revenues don't go up quite as fast, and so you get this squeeze. And when you get the squeeze, the response is we're going to cut services. And so there's a lot of services that hotels used to routinely provide. I don't know if you've noticed, but minibars are going away, right? Minibars, so you have food in the room. Minibars turn out to be a horribly inefficient thing. It's bad for you because you got to pay like $17 for peanuts. And it's bad for the hotel because those peanuts, they have to keep track of how long they were in your room, right? And since they're $17, they never get sold, and so they have to go around to all the rooms and see like what's the date on the peanuts, and that's incredibly labor intensive, and so they have to raise the price of the peanuts, and it's sort of a vicious cycle. So mostly hotels are getting rid of that in exchange for those little kitchens or pantries down by the front desk. So this lets you kind of go back, right? You can get back to the food and snack in your room, but without having to tip. Right, it's one of the things people love. It's another user testing thing. People go crazy about. They don't have to tip. Like, really? Okay.
Have they complained that it's hard to dress up for holidays or events?
They always ask us to dress it up, and you know the bottler. You saw the video. The bottler. They put this. Everybody calls it a bow tie. They claim it's a collar, but whatever. They dressed it. The first version, the picture they sent was amazing. In terms of like really trying to dress it up. We've basically gone to the point where we've said, okay, there's a certain, so far that we want to go, and there's so far that we really don't want to go. So, on a regular basis, you don't want to have loose clothing and things that are going to hang off and get caught, so we don't want to dress it with clothes. You can dress it with vinyl quite nicely using auto wrap technology from 3M. You can, we're sort of saying you what? Well, we do, yeah, in fact.
Well, I'm an artist. If I wanted to paint beautiful things on it, can I do that?
I don't know yet. We should talk. Part of that is sort of a business model question, right? If I sell it to you, and you can go paint it. If I put it in a hotel, I don't want you just to go over and start painting on it without the hotel's approval. And our current business model is that we're putting it available as a service as opposed to selling it. But that's on the other side. The skins, once you get into production with plastics, are not that expensive. So you could paint it, and then if I didn't like it, I could take the skins off and put new skins on. Yeah.
What's your hope for list price for this?
So we haven't announced yet, but we're trying to keep it in a reasonable monthly fee that comes in as a, very inexpensive. Basically, is our model. I'm sorry, I can't say more yet.
Never mind the price. What's the cost to build? You can figure out how to make it back.
Let me answer that in this way. It turns out it doesn't matter as much as you would think, given this business model, right? Given our business model of renting it on a monthly fee, the two factors in the cost are the cost of the hardware and the cost of the service, and they're about equal if you amortize out over 3 or 5 years. So it's really, at this point, we might take a trade-off and make a higher BOM cost in order to get more reliability. Just like if you were building, it's like you're building your own home, you're going to do it right? If you're building a home that you're planning to flip, you might cut some corners, right? We're not planning to flip these, so we're not cutting corners. And because everything is about how we're going to make it so that we're not going to have to service it as often, because that'll save us money in the long term.
So how do your customers look at the value of this? Is it replacement of, room service people? How do they go about deciding?
Yeah, I don't think it's not replacement of room service. It could be the staffing can change with any technology. The way that you staff can change, and so that's clearly one way that they can look at the value. They can also look at as with this robot, you can now offer not room service, which implies like a guy coming in your room and setting a white tablecloth and everything, but you can imagine this doing kind of a grab and go. Different hotels have different policies. So some hotels, you can order stuff from outside, but they won't let the delivery people go up to your room, right? Well, now they can offer that service all the way to your door. So that's the kind of service that can be offered. So I think it's a combination of the marketing value in the short term, the labor savings, if that's appropriate, or the process improvement, if you want to look at it that way, and then the ability to add new services, which might actually increase revenue. Yes?
Kind of following on that question then, like the delivery, have there been any requests or like how do you make it big enough to hold a pizza then?
Exactly.
Yeah, that's one of the things that's really hard. And yeah, we haven't figured out how to make it. It's a small pizza, and that's actually it's a good question. The size of the robot and the scale of the robot is driven in this generation by, we want to keep the footprint as small as possible, because when you go in the elevator, every inch of additional diameter means it's that much harder to be around people and to squeeze through. We want to be able to go down the hallway, and like I can squeeze through this gap without even turning, right? The robot doesn't actually fit through that gap, and that's at this size. So if I make it smaller, I have even smaller pizzas I can deliver, right? If I try to hold up like this, like I could balance a pizza on here, right? You can imagine it wouldn't be hard to put a pizza on top. But now, how am I going to make it so that I don't slap somebody with that pizza when I'm driving around? We keep it all within a cylinder so that we can reason more efficiently in 2D. Yeah.
I was struck by the video of the little girl in the party dress, enjoying her. It was almost like Alice with the March Hare, going through. High technology is often a draw, at least in the early stages. Walt Disney put in monorails partly as mass transit and partly because it added ambiance to its theme parks. Chuck E. Cheese had robots as the main thing. I would think that just having this thing wandering the halls when they weren't needed or during the off-peak hours, having extras of these,
Absolutely.
just wandering around would get people's attention, make them become aware that they could buy things using this service and buy into it.
Yeah, that's right. Actually, one of the things that we're...
Plus security. And
Yeah. I mean, I completely agree. And we talk about free interactions. So the interactions you can do when you're not on a task with people. And we've been thinking about, what are the other things you could do with it to kind of get it out there and get it used? Because you do see a lot of people, like we've seen tens of people who've chosen to stay at the hotel just to see the robot. Right? So it is a real phenomenon. Now, it doesn't happen if it's in every hotel, but in the near term, that is a draw. But you should tell all your hotel friends that they should get one.
Yeah. Where are you going to go next after hotels?
So we haven't decided. We're looking at elder care, at hospitals, at restaurants, at office buildings. If it was 20 years ago, like robots have been coming for a long time. If it had actually gotten here 20 years ago, I would have said office buildings, right? But delivering, because printouts and stuff, right? But paper is so 20th century. It's like, even maybe the office is kind of 20th century, although there's still an awful lot of offices out there. But what gets delivered in offices has changed dramatically because of email and because of computers and the internet.
Sure, you could donate one to the fourth floor for Friday lunches for delivering the lunch database group.
Well, we have some to spare. Yeah.
You already sort of alluded to this. How much did their takeout or room service ordering go up so that people could? It's sitting out there as advertising.
Yeah.
Are people ordering more room service so it comes so that they can do their selfie or something?
Yeah. So I don't have good data on the like how much additional revenue.
You might not be charging them.
That's true. I might not be, and that would be a failing of mine because I was here in computer science instead of at the business school. Yeah.
Yeah, but it's a new line of business for them to grab and go.
Yeah, no, absolutely. No, it's definitely something that's interesting. When we first started, the hotels is conservative a little bit about wanting to adopt things one step at a time, and so they said, water bottles and toothbrushes, fine. We're not sending up food. Now they're saying, okay, you can do food, but it's packaged food. And I keep saying, well, I'd love to send breakfast sandwiches up, warm ones, because we have an i7 inside. It'll heat it, right? But we haven't gotten to that step yet. But it's been just a few months, and we're kind of gradually going forward. Yes.
Have there been any talks about changing the architecture? Like, for example, if you've got this thing doing the grab and goes, you don't need to dedicate a chunk of the lobby to have the grab and go space. You could just put it in a back room or out of the way somewhere and have it.
I think
dispense.
I don't know if anyone's had that conversation. It's a little bit early, right? We kind of sprung this on the hotel industry and the world in August, so I don't think they've thought about re-architecting quite yet. But hopefully, that would be nice. The Aethon Tug. They've been around for long enough that as people build new hospitals, they have been thinking about how could you change the storage. So exactly what you're talking about. And they talk about that as one of the ways that they can make progress. It's just that you don't want to, as a startup, have a business that's based on only going in when a new building is built, unless you have a really good margin. Yeah, yes.
Speaking of really good margins, 18 months, how did the funding, how did et cetera, Stanford, answer the Stanford question. How did you do the startup, funding, milestones, which VC firm, yada, yada, yada?
So we started, so the team, the founding team came out of Willow Garage. Willow Garage shut down last year in August, a year ago August. A bunch of us decided that we wanted to do a company that kind of was doing something along the lines of robot for the service industry. I had announced in Willow internally in 2011 that by the summer of 2014 we'd have a robot in beta. We almost got there. We had the robot in beta. We just the company shut down 9 months before that. But it was an alpha, I guess. So a bunch of us, more people than actually founded the company, were considering joining it. So we all sat around Izumi's dining room table for a month in September. We tried coffee shops. They're a little bit noisy, and we tried libraries, and they have all these quiet rules and stuff. So we started going in the dining room and just sitting around the table. Everybody had their laptop, and we were brainstorming. We knew a lot about robotics. We knew about what could be done. We didn't know as much about what needed to be done, so we focused all on the market side and needs, and concluded that delivery was something we wanted to do. So once we had that stake in the ground, I hired everybody. And the way we got started, we had a contract that we were doing that was profitable, so we had some extra cash from that, and I put some of my own cash in to get going for the first few months. And then we went out and started raising money. Once we had that prototype, the one that the flames was behind the flames, that prototype we could take in hotels and we could have it drive around the lobby. It wasn't doing elevators yet, but that was enough to get the hotel people interested. Then they were willing to talk to some of the funders. And in the end, it was the fact that we went to the Aloft in Cupertino. We got lucky because that's the technology adoption Aloft, and they're already a tech-forward brand. So the first thing they did was call Starwood headquarters, and we were soon in touch with the global brand manager, who was then on, when we were raising money, was on the phone with people saying that he was interested. So I had brand level and I had general manager level interest. Once you get that interest, then you can hopefully get angel funding. And we got lucky. Jerry Yang and Ash Patel came by and liked what they saw. And so they led the round, which ended up being about 10 funders, kind of an angel round, including Google Ventures.
But Scott didn't give you money, or Larry?
Scott is not in this round. Well,
Okay.
Larry's not in the round, but Google Ventures was in the round. So.